Before we go to rotation matrix, I would like to outline something. That is the way we represent the vertex matrix. So I've made examples and I've talked about properties of vertex matrices. So the example that I made was of the vertices 2 and 3, 5 and 7. And I said that the first column will be our x coordinate or correspond to the x coordinate, and the second column will correspond to y coordinate. But take note here on the notes that your vertex matrix, you have your first row with x coordinates and your second row with y coordinates. It is important to note that there can be multiple valid ways to represent geometric data using matrices, and different authors or contexts may prefer one representation over another based on factors such as convenience, mathematical properties, or compatibility with specific algorithms or applications. The representation here is commonly used in various contexts, including geometry and computer graphics. For example, for a triangle with vertices, say x1, y1, x2, y2, and x3, y3, the vertex matrix will be x1, x2, x3, y1, y2, y3. This matrix has two rows, one for x coordinates and one for y coordinates, and three columns, one for each vertex. So each column represents the coordinates of one vertex, with the first row representing the x coordinates and the second row representing the y coordinates. This representation is intuitive and convenient for certain operations, such as performing transformations on the vertices of the shape using matrix multiplication. So we're going to be using this representation throughout, not the one that I talked about, but they're both valid and they're both correct.